Hi everyone. This is a review 2 about project AI chatbot based chest X-ray analysis. Under the guidance of Dr. Santosh Kumar M. Sir, congratulations and welcome you all. And our teammates are Shalini, Srishti, Srinidhi. And this phase 2 is going about the test cases mainly. So, how they are implemented, how the errors are corrected. That will be the next continued by Srishti.
Good evening, everyone. Today I am here to explain about the system design and architecture. Here the contents are system design and architecture and testing and validation and application and the usability. And now here I am going to explain about the system design and architecture. And system design in system design and architectures. Uh, there are mainly system requirements that are inputs. Inputs are chest X-ray analysis, chest X-ray, and DICOM images of the patient. Here DICOM is a file. It is a standard file format which is used in the medical imaging and functional requirements. Image pre-processing. It includes resizing and normalize and DICOM supports, which is help for the image pre-processing and deep learning based disease detection using CNN models. CNN is the conventional neural network model, which is a type of deep learning model, which is a help to analyze in the deep learning models like audio, video, and sometimes text and images. And non-functional requirements are scalability to large medical image dataset and easy integration for the hospital or diagnostic users. And here we have the hardware and software requirements. In hardware requirements, we have Google Colab environment with a GPU support, and Google Colab is a free cloud based platform from Google that allows us to run the Python program. And the GPU is the graphical processing unit, and is Intel Core is like a CPU, and the minimum we have minimum 8 GB RAM and a storage of 10 GB for the data set. And in software side, we have the operating system, Windows, Linux, and Collab. The project, this Windows system, the project runs on the Windows. It helps to run the project. And languages are Python. We use 3.12.1 as a Python as a languages in Python. And frameworks and libraries are TensorFlow, Keras, which is help for the model building and training, and Skitlearn for help for the model evaluation for machine learning algorithms like SPM, regression, clustering, etc. OpenCV is help for the image processing and computer vision task, which is help for the OpenCV help for the detecting faces, objects, and etc. And here we used a Matplotlib and Seaborn. Matplotlib and Seaborn, which is help for the visualizations, and tools are the Google Colab, GitHub, and Google Drive. These are the hardware and software requirements we used in our project. Next. And Resonant 50 layer architecture, Resonant 50 architecture diagram. And here we have the in the Resonant 50 flowchart, we have Convo 7 into 7, max pool 3 into 3, and the residual block. There are four stage residual blocks are there. Residual blocks are the main part in the Resonant 50, and global average cooling and denser flow. And resonant 50 is a deep conventional neural network with 50 layers, famous for introducing residual learning. And here we have the input image. We start with an input image, and Convo 7 into 7 is the first layer. It is an first layer in the conventional layer with the kernel size 7 into 7, and which purpose is extract initial features such as edges, gradients, colors. And max pool 3 into 3 is the 3. This is a 3 into 3 max pooling layer with straight to purpose, further reduces spatial size and keep important features while discarding the invariant details. And residual blocks. Residual blocks are the main part in the resonant 50, and it contains the each block contains the conventional layer, batch normalization, and relu activations and skip connections. And here global average pooling converts each future maps into a single value. In a global average pooling, each converts each maps into a single value, and output becomes 1D vector and dense final layer that perform classification usually, yeah, and it gives the classification of the final layer. And modular design, in data a modular design, we have the data acquisition and the pre-processing. Here in it reads the DICOM and PNG files. In data acquisition pre-processing, it reads the DICOM and PNG files and handles missing metadata and converts grayscales to RGB and normalize. And dataset management, in dataset management, we are going to train the train and validation and test splits using the train test splits, and handles a class imbalance via class weight. And model development, in model development, we have the base model like a resonant 50 and CNN layers. There are four layers: global average pooling, dense, dropout, and output layer. Here is the loss function is the binary cross entry, and optimize is the uh, next. And in model training and optimization, it includes the callbacks, early stoppings, reduce RON, plateau, and model checkpoints. And it also includes the fine tuning, unfreezing the top layers for the better performance. And in evaluation and visualization, generates the classification reports, ROC, and PR curves. Here we can classify the positive and non-positive cases and components accuracy. Here we can detect the accurate precision of the patients. And prediction interface. It includes load saved Keras models. Prediction interface includes the Keras models, accepts new access image for the prediction and output devices. Diseases label. And this is the system structure representation. As I told earlier, it includes the image input image like X-ray, and then we can go to the pre-processing module. Here we can resize the model and normalize, and using the DICOM file. And next we go to model for the resonant 50 CNN features. It includes features, extraction, and classification. Next last is the output layer, which gives the analysis, or which gives the positive accurate output of the patient. And this is the output of the pneumonia test cases. Here, the accurate the con here the confidence level is 99%. It means the patients have the positive cases in the pneumonia, because it accuracy is 99%. So the patients have the positive cases in the pneumonia. And the next slide. This is the cases of the tuberculosis test cases. This is the image of the tuberculosis test cases. Here the prediction is normal with the confidence level 0.94. Here there is no positive. There is no positive in the patients. So here the patient is normal with the confidence 0.94. Next will be explained by the Srinidhi.
Hello everyone, myself Srinidhi. I'm going to explain about testing and validation, developing and executing a testing cases to verify the correctness and functionality of the disease detection models, inputs and scenario. The model works correctly under the all conditions. The predictions are accurate and reliable. The system behaves consistently across different data sets and inputs. We can see in the table. And test case one, in scenario input normal X-ray images, expected behavior is predict as normal, because we given a image as a normal. In test case two, input pneumonia is infected image. So the expected behavior is predictors has pneumonia. In test case 3, input is given a TB is infected image, predicted has a TB infected. In test case 4, input corrupted, unreadable image, error handling gracefully. And next one is input DICOM file without metadata, system correctness metadata process. Next slide. Here are the some images of test cases. First one is normal. There is no effect in this. In pneumonia, in pneumonia, upper part is affected with white patches. In tuberculosis, lower and middle part is filled with the white patches. Fourth one is unreadable image. Fifth one is DICOM file. Next image. Next one is validation against expected results to confirm reliability, accuracy, and consistency of the model's output. Validation methods data split into 80% of training data, 10% of validation, and 10% of testing. Matrix uses accuracy, area under ROC curve, precision and result, F1 score. Accuracy means definition is TP plus TN divided by TP plus TN plus FP plus FN. Used for balanced classes, and you want overall correctness. Misleading on imbalanced data, example 90% gives to accuracy 90%. In area under RUC curve, area under the RUC curve which plots true positive rates, precision and result. In precision and results, TP divided by TP plus FP of the predefined positives and some of the false positives in F1 scores. Harmonic mean of precision and results, F1 like is equals to 2 into precision and result divided by precision plus recall. Next, visualization tool, ROC curve, precision recall curve, confusion matrix, and here is the observe performance. Matrix is accuracy in pneumonia model 98.29%, in TB model 97.15%, in area under ROC curve 0.9969, in TB 0.995, in precision pneumonia model is 0.964, in TB model is 0.92C5. Recall is in pneumonia model 0.927 and TB model is 0.90. Next one is error analysis and debugging. Identified issues, missing or corrupted DICOM metadata, minor misclarifications due to lower quality or unclear X-rays, class imbalance leading to a biased predictions, overfitting during early training phases. Missing or corrupted DICOM metadata, like DICOM files contain images, pixels, and metadata tags such as study data and modulatory. Missing or corrupted tags can break a image reading, reselling, or HU unit oriented downstream. Next one, debugging. Minor misclarification due to a lower quality or unclear X-rays is manual review. Image qualities, matrix distributions, examples, variance. Next one is overfitting during early training phases. Training accuracy very high, but validation accuracy is low. Learning curves, training loss, validation loss quickly, and loss or corrupted inputs to large model capacity and databases. Debugging actions taken, issues and solution implemented. Here missing data is added a default transfer syntax ID handling and actions over used early swapping, dropout layers, imbalanced data, applied classes weight during training, misclarifications is added image augmentation and fine tuning. Here is the outcome is improved robustness and reliability on unseen data, also enhance the accuracy and documented all issues for the traceability and future improvement. Next one will be continued by Shalini.
Okay, now it is visible. You can proceed.
I'm going to explain about application and usability in that implementation with tools and technologies. The system has been designed with the focus on both technical efficiency and real world usability. And in this, the front end is built with React JS. And that it ensures the healthcare professionals and users experience smooth navigation, fast page rendering, and an interactive dashboard for visualizing X-ray analysis. And the backend is implemented using Python. It is integrated with deep learning frameworks such as TensorFlow and Keras. These frameworks enable the system to perform accurate medical image classification tasks by analyzing X-ray images through trained CNN models like ResNet 50. This setup allows efficient handling of complex computations in pneumonia and TB detection. And the RESTful API, it acts as the communication bridge between the front end and the back end, and it allows the front end to send the medical image data to the backend securely for processing, and then receives prediction results. And this ensures a smooth and responsive user experience. And the application is designed to support multiple medical image formats like DICOM, JPG, and PNG. It makes it compatible with the diverse hospital image systems. And to maintain system reliability and stability, the application includes error handling and logging mechanisms. And it user friendliness and accessibility. This system is designed with a strong focus on ease of use, accessibility, and clarity. It ensures that medical professionals can interact with it efficiently, regardless of their technical expertise. And it also includes drag and drop interfaces, which allows user to upload chest X-ray images quickly. And this feature simplifies the diagnostic workflow. Uh, and once the image is uploaded, the system provides real-time predictions results through visually engaging probability distribution bars. For example, if in case the pneumonia is 90% and the normal is 10%, it gives the doctor immediate interpretable view of model's diagnostic confidence. uh, and the system also displays clear status messages and confidence scores. It helps the users understand understand not only the model predicts, but also how certain it is about that prediction. Um, and To make the platform accessible to broader audience, it features a clean responsive design with clear labeling and simple navigation. And it is also accessed through desktop or tablets. The interface remain visually consistent for every user. And additionally, a user feedback loop is incorporated, and it allows the user to report issues and share suggestions or provide feedback on prediction accuracy. And this helps continuously improve the system performance and usability. And informative disclaimers also included. It reminds the users that this tool is not meant to assist. It is meant to assist, not to replace. And the professional medical judgment, it ensures a responsible and ethical use of AI in the healthcare sector. Next is continuing by Arshita.
Okay. In real world applicability, it will helps detecting pneumonia from chest x-rays quickly and accurately, so which saves the doctor's time during the initial days of the diagnosis, and useful in remote or resource limited areas where doctors are less, and rural clinics and hospitals, telemedicine centers can use this software. So where the radiologists or experts are not available all the time, so early detection saves the lives. So um, the TB and pneumonia test cases are diagnosed, and doctors can start treatment earlier, so which can prevent complications in a patient health and improve patient recovery also. And confidence in results, the software does not only gives the yes or no type of answer, the where there is a tuberculosis or not. It will help how confident is the system about each output, each diagnosis. So it is easier to integrate in future health electrical health records or hospital systems, and expand it to detect other chest diseases also in the future. So by the conclusion, in real world healthcare settings where rural or overcrowded hospitals, radiologists often face a huge number of chest x-rays each day. So this AI chatbot, which includes both tuberculosis and pneumonia, the first level screening may happen, which will assist the doctors and quickly flagging potentially interfaced cases for the further review to the doctors. And this solution demonstrates how artificial intelligence can make a real difference in saving lives and improves diagnostic efficiency worldwide.
Okay, your presentation PPTs are very nice. Good design you have followed, and the PPTs presentation is also good, but still it needs some requirement improvements, right? Go back to the slides. Slides, Yogi. Okay.
Sure.
Go to the design of RSNet, architecture of ResNet 50. Yeah, here. Srishti, can you explain what is the residual block is all about? Okay. Okay. What is the difference between residual block and global average pooling? Don't know. Okay. Go to the next slide.
Sure, everyone should answer, or the one
No,
you.
only which I am asking, which whom I
Sure.
am asking.
Okay. Yes.
Okay. Okay. No, back. Previous slide. Okay. Here you're talking about global average pooling, dense dropout, and output layer in the last model development. How do you achieve this thing? Global average pooling and then dense, then dropout, then output layer. What is actually this thing?
So global average
Wait,
pooling is okay.
Srishti will answer. Do you know the answer? If you know the answer, you say yes. Otherwise, you say no. It's okay. Just I'm checking how much you have understood your model. That is my intention. Don't know. Srishti, your mic is muted. You can, yeah. Now you can
Sorry,
answer.
sir. Sorry, in Resonant 50, there are four stages are there, and four stages means four layers are there in model development. There are average pooling layer and dense layer and dropout and output layer. These are the four layers which were used in the model development. In global average pooling, this is the main layer. This is the main layer in the modular design, sir. And resonate 50.
What is actually it is needed? Why it is needed? Global average pooling. Why you have to? What is that actually that layer is required? Why we are using in the RSNet 50?
Sir, to batch normalization and to differentiate the normal and positive of the
What do you
patient.
mean by batch normalization?
Sir, which divides the normal and positive cases of the patient depend on the inputs.
Okay, come to the next slide. Okay, here you are talking about in the evaluation and visualization, generates classification reports and ROC and PR. What is this ROC and PR curves? How it looks like?
It's, don't know, sir.
Srishti, Srishti has to answer.
No, I don't know, sir. I don't know.
Okay. Okay. Srinidhi, can you answer this? What is ROC and what is AUC? How it looks like and why it is called so?
Sir, ROC curve, it's an area under ROC curve, sir.
Oh, what is that area under ROC curve?
Uh,
Do you have any image or can you explain it properly?
Sir, it's area under ROC curve means which plots the true positive rate like TRP is equals to recall versus false positive across the threshold, sir.
No, area under ROC means what? ROC stands for what?
ROC.
Okay. Come to the next slide. Next. Next slide. Okay, next slide. Okay, here you are talking about the third test case. Input DICOM file without metadata and system corrects metadata and something you are telling. Can you explain, elaborate that particular part?
Uh, input DICOM file without data. Without data means it's like let me explain.
Don't know.
How is that?
Okay.
No, no, sir.
Okay, next slide. Next. Okay. Now the question is to Shalini. Shalini, can you explain what is AUC? And in your output, you are talking about confidence. And here, nowhere you are talking about the confidence. How you are relating the output of these parameters and your output as a confidence.
Confidence means how much the model is confident about that particular prediction.
No, how it is related with these parameters. You have so many parameters, right? Recall, precision,
Yes,
accuracy, and
yes.
how this is related. How you are calculating confidence level or confidence of the model. Do you have any relation or do you have any formula?
AUC is ranges from 0 to 1. If the AUC of a prediction is 0.5, it is the confidence level is much,
Random.
much lower, random. If the AUC value is 1, then it is fully confident about that prediction. If it is lower than 0, it it is the worst case.
Harshita, can you show me the curve, ROC curve with an image or an output and explain me what is ROC and what is AUC?
Okay, sir. This is
Do you have output of that curve?
yeah, sir.
Hmm.
Sir, is that visible, sir?
Yeah, visible.
This is the ROC curve where in x-axis false positive rates are present and in y-axis true positive rates are present. Where false positive rate means in how many negative images or negative cases predicted as positive, that is false positive rate. And in true positive rate, how model correctly identifies the true images, that is positive images. So it firstly the from beginning also it is growing means it is always predict the images correctly, means positive means positive. And after reaching one point, after reaching the threshold point, it becomes the normal curve, means linear curve, sir. So area under this curve means that is how much AUC that will be calculated using some formulas, the area under the curve. This means this curve, and so that will becomes 0.998. That means the how the model differentiate between the TB cases and the non-TB cases, or pneumonia cases and non pneumonia cases efficiently.
Can you show me the graph of validation and testing?
That has not done in pneumonia case, sir. That only ROC curve and a precision recall curve done under pneumonia, and the you are asking curve is done here, sir. Validation TB case only.
Then the output shows here your model is not working fine. The model has to start gradually, it has to train, you have to train your model, and gradually it has to increase the what accuracy, and it has to stay at the some level, it has to become stable after some level, but it's coming down and again going out.
So
So
for some cases, for some TB cases where the picture is not correctly visible, or picture is uh, um, infected with the other noise and all, the model is not predicting correctly. That's why it's showing the low level. After some images or epochs, in some epochs, it will be raised gradually. So you can see here in that
yeah,
validation case.
yeah, actually, when you have when you increase the epochs, so at
Yes.
least from 0 to 10, it has to gradually increase the accuracy, and after 10, it has to maintain its consistency at least for 20 epochs. But it is suddenly for after 12 epochs, it is suddenly coming down your validation graph.
Maybe
Some,
data set.
somewhere maybe the data is not properly you have given the training, or the data is outlier, so you may have some data which is outlier data, you may have given as an testing data, so that may be the case.
Yes, sir.
So if you want to present it in the, or if you want to publish a paper on this, or if you want to present it in the international conference, then you have to redo this model, and you have to create something good model which will maintain the consistency in the accuracy level, right? Okay,
Yes.
so what for the bachelor degree level, it is very good. So whatever you have done is very good, but still you need some extra work so that you can improve your model. Okay.
Yes.
Okay. Okay. Overall, it was a nice presentation, and you have done almost two. You have taken two diseases. That is a plus point for your project.
Yes.
Usually, even in the PhD level, people will take only one disease, but you have taken two diseases. That is an advantage. And other thing is the presentations, PPTs are very nice, but still you have to improve a lot, especially Srinidhi and Srishti. Still improvement is required. Srinidhi, somewhere you are pronouncing the some words is not accurate. Like accuracy, you are pronouncing it as an accuracy, and some words are what mispronounced, and you have to improve in that presentation.
Okay, sir.
Otherwise, it was a good presentation. And Srishti, you have taken some challenging task in explaining the ResNet model, but still improvement is required. You should take some example how a ResNet works, and if you have taken some animations also, then that will be a better presentation in the coming days. So in the final presentation, try to add some animations for and give some examples how ResNet 50 will work.
For
Once
next
it is
for
done,
next review, sir.
yeah, for next review, it could it makes your presentation still better. That is the only what suggestions from my side.
Yes, sir.
Overall, it was nice. Okay,
Sir,
thanks.
the video should include a question and answer phase, sir.
Which one?
For
Animation.
uploading at
Yes.
YouTube, for uploading to the
Yeah,
YouTube. Sir.
everything should be there.
Okay, sir. Yes, sir.
Thank you.